When we think of records in society, which we don't often do, most of us, except for those of us who are obsessed with records, being an archival scientist, that's me. We don't really think about it as the quote here from Sir Hilary Jenkinson, one of our foremost archival theorists. We exist to make other people's work possible. We exist to make our lives and our social institutions possible. So, just think about if you did not have access to records, all the ways in which you use and you interact with records, whether that be through your birth certificate, which is something that you use to prove your identity, whether that's through your health care card, for example, which is something that entitles you to health care. And whether it's the receipt that you got for the purchase of something that entitles you to a warranty for that, that item that you purchased, or to be reimbursed for an expense or something like that. So in all sorts of different ways, we interact with records in society. They structure our social institutions, in fact. So if we didn't have records, and in particular, if we didn't have records that we could trust, we would find that we would not be able to function very well. So we need records we can trust, and we need those records to actually be trustworthy for as long as we need them, and in some cases that's a very long time. For example, think about your birth certificate. You need that at least for your lifespan, and those who might, inherit citizenship from proving that you were born in Canada, for example, might need records of your birth to persist for a very long time. And your descendants, I should say, who follow after you, who might be interested in, their forebears and where they came from, might actually want those records to persist in a trustworthy form for many, many centuries after your birth. So we do want our records to be trustworthy. We do want them to be immutable. But how do we know if they are? Well, there are many ways that we know that whether they're trustworthy or not. And archival science, as a discipline, which may not be well known to most of you, emerged as a field of study, as a science, in order to do just that. And it actually dates back to the Middle Ages. So the first school, professional school for archivists, which was a notarial school, because this archival science and the notary arts and the law had all emerged sort of together, and then they have taken different directions over time, was in 1158 at the University of Bologna. And it was a course on the study of the ars notaria. And that's where notaries were taught to create documents according to legal and administrative rules, and how to keep registries, and how to organize documents for the purposes of retrieval. So that's 1158. Over these centuries, we have developed ways of measuring or testing whether documents, and evaluating whether documents can be trusted or not, and also theories and practices for how to preserve them. Of course, the way that we create documents has changed over time. So we have here an ancient Roman document, but on the other side we have the new form of record keeping, which is blockchain record keeping. And blockchain record keeping posits that records will be secured cryptographically, but also by its distributed nature, and be kept immutable. Now, I don't propose to go into a lot of technical detail, for those who aren't familiar with the technical details of how blockchain works in this talk, due to limitations of time, but I will just talk about some of the broad features of blockchain and why the supposition is that it produces trustworthy and immutable records. So for one thing, it permits the tracking of transactions from one state to another, so a state change. So when we carry out a transaction, we make some kind of change in the world. We have the intent actually to do something that is going to result in some state change. So the blockchain is designed to track those state changes. And it stores an amount of information in, for example, cryptographic hashes of actual transactions, unencrypted metadata sometimes, computer code if we're talking about something called smart contracts, which is bits of tiny programs that operate over the blockchain. And it's stored on-chain. When it's stored on-chain, it's intended to be immutable and tamper-proof. Sometimes it's linked to other stores of information that are, exist outside of the blockchain. And in this distributed, cryptographically hashed environment, the information is intended to provide a tamper-proof proof of existence of this record of the transaction. For whatever time period, it's intended to provide that proof. Now, transactions, the reason it's called blockchain is transactions are recorded in chunks called blocks, and the blocks are chained together. And they're also chained together by use of these hashes. The hashes are these cryptographic numbers, they're integers, where you can take any amount of input. So you could take the entire library here at the Barber Center, and in theory, you could reduce it to a 256-bit number, and that would be a 256-bit hash. So the blockchain in particular uses SHA-256. And so they're chained together, these blocks, cryptographically, which is what makes it very, very secure, because it's very hard to break that cryptographic hash. It requires a lot of computing power to do it. And it's not impossible, especially with quantum computing coming along, but it's very difficult to do it. You need a lot of compute power. And it employs a peer-to-peer mesh network. So on each node, which is a computer, which stores these transactions, groups them into blocks, chains them together into blocks, it's replicated out to a number of other computers that store the entire blockchain, the entire ledger, or a portion of it. And there's some technical details about how that's accomplished, which I won't go into today. But the idea is that because these are they're encrypted by the use of hashes, and they're distributed out in this distributed mesh network, you can still see the transactions, although you can't, because they're encrypted, actually tell what the transactions are about necessarily, unless there's clear text metadata attached to it. So in this way, you get privacy, but you also get transparency. So it's that is how it works through this distributed, cryptographically secured approach. Now, it, in theory, operates according to a decentralized model. So not only is it distributed on various nodes, but it's also decentralized. In public blockchains, for example, there's no one, in theory, there's no one person in control. So you can't just, if something goes wrong, phone up the help desk and ask for somebody to give you a hand. There's nobody in control. The idea is that the system operates through this computational mechanism called, in the case of the Bitcoin blockchain, proof of work, this consensus mechanism by which transactions are confirmed and entered into the blockchain. They're confirmed as reliable transactions and entered into the blockchain. Now, in practice, there are various versions of the blockchain that are under more centralized control. These are usually private, permissioned blockchains. And even in public blockchains, there are core developers who have some amount of centralized control over pushing out types of upgrades or changes to the core code. There are different ways that happens on different networks. You may have heard about the recent forking of the Bitcoin public blockchain. The forking is where the long chain of transactions splits into two. And so there's this mechanism by which a different version of that blockchain starts to operate on each version of the chain. And so there are core groups of people that will be supporting one chain or the other. But in theory, the idea is that it's supposed to be decentralized, distributed, and cryptographically secured. Okay, so we get from this, in theory, we get trusted and immutable records. And this is very important in, for example, in instances like this example here, where a company called EtoTime is working with Syrian activists and a Berlin-based human rights organization. And these activists are receiving, or they actually capture, direct photographic evidence or video footage of alleged human rights violations. And there's a need, if those human rights violations or the accusations of human rights violations are going to be taken to court later on in the Hague, in the International Court of Criminal Justice, for example, then we need to know that we can rely on the authenticity of those images. And so what this company is doing with these activists is when they capture the video, then that is uploaded to the blockchain, it's time-stamped, it's secured on the blockchain, and then there's a subsequent validation process that goes on that's undertaken by this Berlin-based group to look at the images, to look at their provenance, and authenticate those images. So in this example, that's just one example of where the blockchain is being used to, for purposes of preserving authentic and capturing authentic evidence of, that's important to society. So I've been looking in my research project about how the blockchain is being used in similar record-keeping environments. And I've developed a typology from what I've seen so far of different blockchain record-keeping solutions. So the first one, which I'm calling on a kind of a scale from least novel to most novel in terms of record keeping, is the mirror approach. So using the blockchain for record keeping to mirror an existing record keeping system. And I'll talk about examples of this in a minute. The second one, kind of the halfway, is what I'm calling the digital records approach to blockchain record keeping. And that's where you do actually have record-keeping records being created on-chain through, for example, the use of smart contracts. And the records are being created by multiple stakeholders who are interacting with the blockchain and transacting over a blockchain. And so that's sort of a halfway point between least novel and most novel. And the most novel is where we see not only records necessarily being created on-chain, but you actually see the object of the transactions, what the transactions are all about. So if we're talking about land transactions, for example, the land being tokenized. And what do I mean by tokenized? I mean that that land is, there's a representation of that land. So the land is in some way dematerialized, and a representation is created of it, which becomes the land in essence. It comes to represent the land. And that representation is traded over the blockchain. So you not only have record keeping happening over the blockchain, which concerns the piece of land, but you actually have the piece of land itself trading over the blockchain. So that is the most transformative for our society. And so these are the different types. Let's look at some examples of this then. So the mirror example, an example of this would be what is happening in Estonia with medical record keeping. So the government of Estonia is probably one of the most advanced in terms of using blockchain record keeping. They have an Estonian company that actually predates blockchain per se. After independence of Estonia from the former USSR, they had a lot of scientists and cryptographers, and so they were able to develop some quite advanced cryptographic software. And so the company EtoTime emerged about the time of the Bitcoin blockchain emerged. And it wasn't quite a blockchain at the time, but they've evolved their technology. And so what they've done is they have a medical record-keeping database. So when you go to the doctor in Estonia, everything's done online. Your doctor keeps all of your records, and any medical practitioner that you interact with is going to be interacting with this database where all of your medical records, every procedure, every visit, every prescription is all in this database. So naturally, we're very concerned that A, those records be trustworthy, and B, that those records be secure, because we'd be worried about our private medical information getting out there and being abused, for example. And so it's very, very important that it be, authentic, trustworthy, secure, and of course immutable, because we need the medical records for a long time for our own purposes, but also for medical research when that's necessary. So GuardTime is mirroring this, this Oracle database, which contains all of the government medical records, and through a piece of middleware, this Fusion middleware, it is passed to a private permissioned GuardTime blockchain. And then what they do is they take it all gets hashed up in these Merkle trees, these hashes of hashes, and eventually the top of the tree, that hash, is published out to something like a published newspaper. And that's done so that they can link the transactions to chronological time as opposed to system time. So that's an example of a mirror, where the records themselves still exist in their, their original form, digital form, in the database, but the blockchain system is acting as a mirror containing hashes to secure, to check. So if you wanted to see if those records in the database had been tampered with, you would check, you would rehash the records in the database and compare it with the hash that eventually gets published out to the newspaper, and you can trace it back through the hash. I won't go into the technical details of how you trace it back through the tree. But if you could tell if the hashes don't match, if the records had been tampered with. Okay. So then the sort of the middle way, middle path to innovation is this digital records example. So in this one, this has to do with blockchain-based land transaction recording in Sweden. So in Sweden, they have a multi-stakeholder network, which consists of the buyer and the seller of the property, consists of the banks, and consists of the Lantmäteriet, which is the land registry office in Sweden. And they all interact on a permissioned blockchain, which is called post-chain. And there's a front-end app that the users of the application interact with, and then there's something called an SPLIX smart contract layer, where you actually write the contract for sale on the blockchain. So here we have an example of a smart contract for sale of a property in Sweden. So this is an example of a new type of record. So we saw the Roman charter. We can think of lots of records that we're used to seeing, but now they exist on chain, and they're not written in natural language. They're written in code. And so this is a new form of record. It's still quite innovative. We're not used to dealing with these kinds of records. We don't know about their legal status, for example, as records, their admissibility as evidence in court. We have lots of questions about how to deal with these records. But this is what the future of record keeping is going to be for us in some ways. And then we have our most innovative system. And so in this system, we have the land itself being tokenized and turned into a record. And so in this system, we not only have the potential, they're not doing it just yet, we have the potential to create the record on chain using smart contracts. And we also have, so we can conduct our business, the record-keeping aspects of our transaction on the blockchain. Not only that, we can trade the land itself. We can trade the land itself. So the land becomes dematerialized and actually exchanges over the blockchain in a peer-to-peer network. So in this case, you can see here we have the front end of the system, and I'll just mention the front end sits on a server in the US. We have a web server there. We have it uses the public Bitcoin blockchain is the platform that they're using to actually trade the land and record the transactions, and it uses something called colored coins. And in this case, it uses a version of the colored coins protocol called Colu, and Colu is based in Israel. And then it secures it onto the Bitcoin blockchain, nodes of which exist. There are over 5,000 nodes of the Bitcoin blockchain all over the world. Right? Now, metadata concerning the piece of property that describes the property with its geographic location, that's actually recorded on the BitTorrent decentralized file system. So again, it operates like the blockchain, where the nodes are decentralized and they exist all over the world. And there's also the metadata is stored on the Colu local server. Okay, so you have the situation where you have the records are not just in one centralized place like we're used to maybe in the old-fashioned world where things were in filing cabinets, or even the cloud where we have centralized cloud repositories, although with cloud, you know, it is distributed in the back end. We have a sense of it going into one centralized place, but what's happening on the other end is somewhat different. But this is very highly distributed and highly decentralized, which raises all kinds of interesting questions from from the standpoint of trusting your records. And the interesting thing also about the tokenized example is that, as I mentioned, you know, in a world where everything from land to diamonds to food to fine wine to art, all of this is being tokenized, dematerialized, and so it is possible to posit that everything becomes a record. And just going back to the archival theorist Sir Hilary Jenkinson, he wrote back in 1922, it was republished in 1937 in a manual for archive administration. He spoke about these kinds of tokenized attachments to records as being a part of the record. He says again, there is a case where an undoubted archive consists of an old pair of military epaulettes, and among enclosures to letters forming in each case an integral part of the document. So Jenkinson said, and he even went so far as to say, even a spar of Douglas fir, or even an elephant could be a record. He said it's not a theoretical question, it's an administrative one. As you can imagine, in the days when we weren't able to dematerialize things, it would be difficult to manage an elephant as a record. But now that we can actually digitize everything, tokenize things, and trade them, these can be treated as records as well. And we want these representations, and we need them to be trustworthy, secure, and immutable. Because if we're digitizing our land, we need to know that that land isn't just going to go poof. So there are some issues with that. And again, archival science can provide a valuable evaluation framework. So in archival science, over years, and particularly there's been a lot of research done on this here at the University of British Columbia. We've had a leading research project, international research project, called Interpares, led by my colleague, Professor Luciana Durante. And some of us in the room have been members for quite some time of this project. And so there are some characteristics that over time, drawing upon archival theory and then translating that into the digital world, we've come to determine we can trust records. And things like accuracy. We want our records to be accurate, we need them to be reliable, and we need them to be authentic. We need all of these characteristics to persist through space and over time. Now, there's a lot of theory behind this, and I don't have time to go into all the theoretical details, but this gives us a framework by which we can evaluate blockchain-based solutions that are aiming to manage records, including those tokenized assets. And I'll just say that through an analysis of a number of different cases of blockchain record keeping, this very colorful diagram is what I've come up with to say that, okay, we have some issues here. So if we're looking at the yellow are areas where, yeah, it kind of does it in some cases, and each of the three types of blockchains that I discussed, the mirror, the digital records, and the tokenized, does this to some degree. There are more problems in others than in some. But we have a couple of areas that are in the red, and that's archival bond. That's the name that archivists, archival science, gives to that very important link between the representation, the documentation of the transaction, and the actual facts and acts that the documentation represents. So the transaction that it represents. If you don't have that link, then you have evidence of what? Nothing. You need to have the link back to the business context or the context of the transaction in order to have evidence of something. And in many, many systems, not just blockchain systems, but it is particularly a problem in blockchain systems, you do not have that link. You have no way of instantiating that link. And therefore, if you're trying to rely on this evidence, you have no basis for it. So that's something that needs solving. And the other really red area is preservation. Now there's this assumption that lots of copies means that, if something goes wrong, we'll be able to retrieve the copy. But that's not necessarily the case. We might have one version survive, but is it the complete version, or is it just one of the truncated light nodes, let's say, of a public blockchain? Or if it's a private permissioned blockchain, has the body that's been responsible for maintaining that blockchain gone out of business and left us high and dry with our records? We really need to think through the long-term preservation of these records. And archives, as institutions, not as bodies, collective bodies of records, have existed through time to do that, to perform that function. But in a world of distributed and decentralized record keeping, the centralized model of archiving may be very, very challenged. And I think as archival scientists, we'll have to think about, how does this happen? What will be our role in society? How will we fulfill that role? So to conclude here then, I maintain that blockchain solutions are their heart record-keeping systems as distributed ledgers. That's probably one of the important things about blockchains, that they produce these secure, or the intention is to produce these secure, immutable records. And it's quite surprising that we haven't, designers are not relying more on archival science. I encourage you to, because I think it provides an excellent evaluation framework. That these systems are now maintaining extremely important societal records like medical records and land records and more besides. As I mentioned, archival science can provide a good evaluation framework, and that many solutions are still falling short of what archival science would consider to be trustworthy records that can be preserved as immutable and authentic over time. So let's continue the research. Let's work together, as blockchain at UBC has already started to do with Land Titles and Survey Authority of BC, and other blockchain solution developers. And yeah, we look forward to actually helping this technology to achieve the vision of secure, immutable, and decentralized record keeping.